The sun, our life-giving star, is a restless giant. It is not a constant beacon of light and heat. The sun experiences cycles of activity, periods of calm punctuated by bursts of intense energy. We are now entering a period of heightened solar activity, a time when the sun's fury could be unleashed upon our planet. This is not science fiction, it is a reality we must confront. Solar storms, massive eruptions of energy from the sun's surface, pose a significant threat to our increasingly technology-dependent world. We must understand this threat and prepare for it. Our technological civilization, our interconnected world, is vulnerable to the whims of our star. Imagine a world without electricity, where communication networks crumble and satellites fall silent. This is not a scene from a disaster movie. It is a potential consequence of a major solar storm. The time to prepare is now. Before the sun's fury catches us off guard, we must heed the warnings of scientists and engineers who understand the risks we face. We must take steps to protect our critical infrastructure, our communication systems, and our way of life. The future of our technological civilization may depend on it. The sun, like a beating heart, pulsates with a rhythm that governs its activity. These pulses, known as solar cycles, last approximately 11 years and are characterized by periods of relative calm and intense activity. At the peak of this cycle, known as solar maximum, the sun is a cauldron of activity. Sunspots, dark, cooler regions on the sun's surface, proliferate, and solar flares, sudden bursts of energy, erupt with greater frequency and intensity. Conversely, during solar minimum, the sun slumbers, sunspots are scarce, and solar flares are less frequent and powerful. However, this does not mean we are entirely safe. The sun is capable of unleashing powerful storms even during periods of relative quiet. Moreover, there are longer-term cycles, such as the grand solar minimum, which can last for decades or even centuries, during which solar activity is significantly reduced. Understanding these cycles is crucial for predicting and preparing for the potential impacts of space weather on our planet. By studying the sun's past behavior, we can better anticipate its future and take steps to mitigate the risks posed by its inevitable tantrums. The sun's fury is not a new phenomenon. For as long as humanity has gazed up at the sky, the sun has been both a life-giving force and a source of awe-inspiring power. Its surface, a roiling sea of plasma, occasionally erupts in massive solar storms that hurl charged particles across the solar system. Throughout history, Earth has been bombarded by solar storms, some with surprisingly little impact and others with devastating consequences. These storms, known as geomagnetic storms, occur when solar wind interacts with Earth's magnetic field, causing disturbances that can affect everything from navigation systems to power grids. In 1859, the Carrington event, the largest solar storm ever recorded, unleashed its power on an unsuspecting world. Named after British astronomer Richard Carrington, who first observed the solar flare, this event was a wake-up call to the potential dangers posed by solar activity. Telegraph systems, the cutting-edge technology of the time, went haywire, sparking fires and delivering electric shocks to operators. The telegraph lines, which spanned continents, acted as giant antennas, picking up the geomagnetic disturbances and causing widespread chaos. Auroras, usually confined to polar regions, were observed as far south as the Caribbean. These spectacular light displays, caused by charged particles colliding with Earth's atmosphere, were a visible reminder of the storm's reach and intensity. The Carrington event serves as a stark reminder of the sun's immense power and the potential consequences of a major solar storm in our technological age. Today, our reliance on technology makes us even more vulnerable to such events. More recently, in 1989, a solar storm knocked out power to millions in Quebec, Canada. This geomagnetic storm, though less powerful than the Carrington event, demonstrated how even a relatively moderate solar storm could have significant impacts on modern infrastructure. This event, though less powerful than the Carrington event, highlighted the vulnerability of our modern power grids to the sun's outbursts. Power lines and transformers, essential components of our electrical infrastructure, are particularly susceptible to geomagnetic disturbances. Imagine the chaos that would ensue if such an event were to occur today, impacting our vast and interconnected power grids, communication networks, and satellite systems. The ripple effects would be felt across the globe, disrupting daily life and potentially causing economic turmoil. The economic and societal impacts would be profound. Stock markets could crash, communication networks could fail, and entire cities could be plunged into darkness. The interconnected nature of our world means that a solar storm's impact would not be confined to one region but would have global repercussions. These historical events serve as stark reminders of the sun's potential to disrupt our lives. They highlight the need for vigilance and preparedness in the face of natural phenomena that are beyond our control. They underscore the urgency with which we must prepare for the inevitable day when the sun once again unleashes its fury upon our planet. Scientists and engineers are working tirelessly to develop technologies and strategies to mitigate the effects of solar storms, but awareness and preparedness at all levels of society are crucial. The modern threat: technology at risk. Our world is now interwoven with intricate and delicate technological systems, far more complex and vulnerable than the telegraph wires of the 19th century. These systems are the lifeblood of our modern society, enabling everything from global communication to financial transactions and even the functioning of our healthcare systems. The seamless integration of these technologies into our daily lives has made us more connected than ever before, but it has also introduced new vulnerabilities that were unimaginable just a few decades ago. Satellites, orbiting thousands of miles above Earth, are our eyes in the sky, providing communication, navigation, and weather forecasting. They are essential for everything from international phone calls to GPS navigation in our cars and planes. Without these satellites, our ability to communicate and navigate would be severely compromised, affecting both personal and commercial activities on a global scale. Power grids, intricate webs of interconnected generators and transmission lines, deliver electricity to our homes, businesses, and essential services. These grids are the backbone of our energy infrastructure, ensuring that we have the power needed to run our appliances, charge our devices, and keep our lights on. The complexity of these systems makes them particularly vulnerable to disruptions, which can have cascading effects on other critical services. These systems, the backbone of our modern world, are highly susceptible to the effects of solar storms. A significant solar event could disrupt the delicate balance of our technological ecosystem, leading to widespread outages and failures. The interconnected nature of these systems means that a failure in one area can quickly spread to others, amplifying the impact. The charged particles carried by a coronal mass ejection can interfere with satellite electronics, disrupting communication, navigation, and GPS systems. These particles can penetrate the protective shielding of satellites, causing malfunctions or even complete failures. The loss of satellite functionality would not only affect personal communications, but also critical services such as weather forecasting and disaster response. These particles can also induce currents in power grids, overloading transformers and causing widespread blackouts. The sudden surge of electrical current can damage the infrastructure, leading to prolonged outages that can take days or even weeks to repair. This kind of disruption can have severe consequences for hospitals, emergency services, and other essential operations that rely on a stable power supply. The consequences of such disruptions are far-reaching, potentially impacting financial transactions, emergency services, transportation systems, and countless other aspects of our daily lives. The ripple effects of a major technological failure can lead to economic instability, social unrest, and a breakdown in the services we take for granted. In a world where time is money, even a brief disruption can result in significant financial losses and operational challenges. In a world increasingly reliant on technology, the impact of a major solar storm could be catastrophic, leading to economic losses, societal disruption, and even loss of life. The potential for such an event underscores the importance of preparing for and mitigating these risks. By understanding the vulnerabilities of our technological systems, we can take proactive steps to protect them. We must therefore take steps to protect our critical infrastructure from the sun's wrath. This involves not only improving the resilience of our existing systems, but also investing in new technologies and strategies to mitigate the impact of solar storms. Collaboration between governments, industries, and scientists is essential to develop comprehensive protection plans. This includes hardening power grids, developing backup systems, and designing more resilient satellites. By taking these measures, we can ensure that our technological infrastructure remains robust and capable of withstanding the challenges posed by solar storms and other natural phenomena. The future of our interconnected world depends on our ability to safeguard these critical systems. The fury of a CME when the sun unleashes its power. Among the sun's arsenal of weapons, coronal mass ejections, or CMEs, are the most formidable. These colossal bursts of solar wind and magnetic fields are capable of wreaking havoc on a scale that is hard to imagine. These massive eruptions of plasma and magnetic field from the sun's corona, the outermost layer of its atmosphere, can travel at speeds of millions of miles per hour. The sheer velocity and energy carried by these ejections make them a significant threat to our planet. When a CME strikes Earth, it can trigger intense geomagnetic storms, disrupting our planet's magnetic field and unleashing a cascade of effects. These storms can interfere with satellite operations, navigation systems, and even the electrical grid. The intensity of a geomagnetic storm is measured on a scale called the G scale, ranging from G1, minor, to G5, extreme. This scale helps scientists and engineers prepare for and respond to the potential impacts of these solar events. G5 storms, while rare, can have devastating consequences. They can cause widespread technological disruptions, affecting everything from power grids to communication networks. They can disrupt radio communications, damage satellites, and even cause widespread power outages. The economic impact of such disruptions can be enormous, affecting industries and services worldwide. The 1859 Carrington event is estimated to have been a G5 storm, and its impact on our technologically advanced world would be far greater today. Modern society's reliance on technology makes us more vulnerable to the effects of such powerful solar events. The impact of a CME is not limited to the initial blast. The charged particles can linger in Earth's magnetosphere, causing prolonged periods of geomagnetic activity and radiation hazards. The charged particles carried by a CME can remain trapped in Earth's magnetic field, creating a hazardous radiation environment for astronauts and potentially affecting airline passengers at high latitudes. This radiation can pose serious health risks and requires careful monitoring. Understanding the dynamics of CMEs and their potential impacts is crucial for mitigating the risks they pose to our planet and our technological infrastructure. Ongoing research and advancements in space weather forecasting are essential to protect our modern way of life from the sun's unpredictable fury.